The aircraft uses external air to supply the following systems: the air conditioning system, the ventilation system, the pressurization system, and the de-icing system, described in a different chapter. The pneumatic system consists of all the systems supplying air. Air is generally bled from low compressor stage, low pressure. Air is generally bled from low compressor stage, low pressure. If pressure from the low pressure is insufficient, the source is automatically switched to the high compressor stage, high pressure. This condition occurs when pneumatic pressure drops below 38 psi on ground or below 25 psi in flight, during descent, at flight idle, or on ground. A bleed air shutoff valve is fitted downstream of the low pressure and high pressure ducting. The bleed air shutoff valve is electrically controlled and pneumatically operated. It is spring-loaded to close when there is no air pressure, and it is locked closed when not energized. The bleed valve controls airflow to the pressurization and air conditioning. It automatically closes in case of no air pressure, bleed duct overheat, bleed duct leak, actuation of engine fire handle, up trim signal from the engine alive in case of engine failure at takeoff, propeller brake engagement signal, hotel mode, available only for the engine 1 bleed air shutoff valve. The opening of the bleed valves is inhibited during an engine start sequence. A bleed air shutoff valve is now open. A ground crossfeed valve, located in the crossfeed duct, connects the left and right pneumatic systems. The valve is electrically controlled and pneumatically operated. It is spring-loaded to close when there is no air pressure, and it is locked closed when not energized. On ground, the ground crossfeed valve opens only when air is supplied from the right-hand engine operating in hotel mode. In flight, the crossfeed valve is normally closed. The bleed air check valve prevents reverse airflow going to the left engine compressors when the right engine is operating in hotel mode. The protections are the overpressure switches. The pressure switch is fitted to the bleed air duct upstream of the bleed air shutoff valve. When air bleed pressure is greater than 80 psi, overpressure switches send signals to the multifunction computer, MFC, which closes the bleed air shutoff valves. This condition will trigger a bleed fault alert in the cockpit. The overheat detectors. These overheat detectors are thermal resistancers and are installed after the bleed air shutoff valve. These switches, which are duplicated for safety, ensure that the high-pressure bleed valve and the bleed air shutoff valve are closed whenever any abnormal over-temperature conditions occur. They operate at 274 degrees Celsius, 525 degrees Fahrenheit, and are controlled by the MFC. In case of overheat, the associated bleed system may be recovered after a cooling period. A continuous monitoring system is installed in order to detect overheat due to duct leakage and to protect the structure and components in the vicinity of hot air ducts. Wing leading edge and wing to fuselage fairing, upper and lower fuselage floor, air conditioning pack area. In order to ensure rapid leak sensing, a Kevlar envelope is installed around a major part of the high-temperature ducts to collect and direct leaking air to the sensing elements. Note: a bleed leak alarm is triggered when a leak is detected. Temperature exceeds 153 degrees Celsius in the bleed duct. Consequence: after a 1-second time delay, the associated pack valve, high-pressure valve, and bleed valve, and ground crossfeed valve if the left loop is affected, are automatically latched closed. In case of leak, the crew must consider the associated bleed system as inoperative for the rest of the flight. The air bleed control panel, located on the right side of the overhead panel, is associated with a system display cabin page displayed by default or on pilot request. Observe the relationship between the air bleed control panel and the system display cabin page and their meaning. A dark push button indicates that the engine bleed push button is depressed and the associated bleed valve is open. This push button state corresponds to the on position and normal system operation. On MFD cabin page, label 1 is displayed. A white OFF push button indicates that the engine bleed push button is released and that the associated bleed valve is closed. The push button state corresponds to the OFF position. On MFD cabin page, label 2 is displayed. An amber fault push button and flight warning system activation indicate a mismatch between the engine bleed push button position and the associated valve position. Commanded on, but no air or stuck closed. Fault is also illuminated in case of leak or overheat of air pressure. On MFD cabin page, label 3 is displayed. The overheat amber lights local alert and flight warning system activation indicate an overheat detected in the bleed duct when temperature exceeds 274 degrees Celsius, 525 degrees Fahrenheit. Label 1 is displayed on MFD cabin page. The leak amber light local alert and flight warning system activation indicate a leak detected by the leak detection when system temperature exceeds 153 degrees Celsius, 307 degrees Fahrenheit, sensed through a leak detection system. Label 2 is displayed on MFD cabin page. The ground cross-feed indicator light, cross valve open, extinguished, and this cabin page representation indicate that ground cross-feed valve position is closed and aircraft is on ground on normal condition with 2 engines shut down, hotel mode. The ground cross-feed indicator light, cross valve open, illuminated, and this cabin page representation, label 1, indicate that ground cross-feed valve position is open and the aircraft is on ground on normal condition with 1 or 2 engines running and prop brake is on, hotel mode. The ground cross-feed indicator light, cross valve open, extinguished, and this cabin page representation indicate that ground cross-feed valve position is closed and aircraft is on ground on normal condition with prop brake on off position without hotel mode, or aircraft is in flight on normal condition with 2 engines running. The ground cross-feed indicator light, cross valve open, extinguished, and this cabin page representation, label 2, indicate that ground cross-feed valve position is stuck closed and aircraft is on ground during engine start, in this case it is a temporary situation, or aircraft is on ground with 1 or 2 engines running and prop brake on. In this case, it is an abnormal situation, hotel mode. The ground cross-feed indicator light, cross valve open, illuminated, and this cabin page representation, label 3, indicate that ground cross-feed valve position is stuck open and aircraft is on ground with 2 engines shut down. Or label 4, aircraft is in flight on abnormal condition with both engines running and supplying their own bleed air side. In this case, flight warning system is activated. The ground crossfeed indicator light, cross valve open, illuminated, and this cabin page representation, label 5, indicate that ground crossfeed valve position is unknown, with aircraft on ground or in flight abnormal condition. In this case, flight warning system is activated. We will now observe the airflow during engine 2 start. The aircraft initial conditions are: aircraft on ground. Both engines shut down. The engine 1 and 2 bleed push buttons and pack valve push buttons are depressed on the air bleed panel, and engine 1 and 2 bleed push buttons and pack valve push buttons fault lights illuminated on the air bleed panel, and system display cabin page displayed. The engine start rotary selector is set on A and B. The Start 2 push button is depressed, and the ON green light is illuminated. Engine 2 is starting. Please observe airflow and associated indications on air bleed panel and system display cabin page during engine start. Engine 2 high pressure HP valve opens. High pressure spool rotation speed NH crossing 45%. 30 seconds after NH crosses 45%, the engine 2 bleed air shutoff valve opens. The multifunction computer MFC detects that one engine bleed shutoff valve is open and orders the crossfeed valve to open. Cross valve open. Pack 1 is the first to be supplied. Pack 2 is supplied 6 seconds after Pack 1. We will now observe the airflow during engine 1 start. The aircraft initial conditions are: aircraft on ground. The engine start rotary selector is on A and B. Engine 2 is running and engine 1 is shut down. Engine 1 and 2 bleed push buttons and pack valve push buttons are depressed on the air bleed panel, and engine 1 bleed push button is illuminated and cross valve open on air bleed panel, and system display cabin page displayed. The Start 1 push button is depressed and the ON green light is illuminated. Engine 1 is starting. Please observe airflow and associated indications on air bleed panel and system display cabin page during engine start. Engine 1 is running. Engine 1 high pressure HP valve opens. When the airflow reaches the engine 1 bleed air shutoff valve, two cases have to be considered. First case, propeller brake is engaged. The MFC logic forces closed the engine 1 bleed air shutoff valve and consequently the ground cross valve remains open. Second case, propeller brake is released. When NH crosses 45% plus 30 seconds, the engine 1 bleed air shutoff valve opens. The MFC detects the engine 1 and 2 bleed air shutoff valves opened and consequently closes the ground cross valve. With both engines running and propeller brake released, the ground cross-feed valve is closed. Each side is now supplied by its associated engine bleed. All lights are out on overhead panel and all indications are green on the system display cabin page. Aircraft configuration in flight. Power levers, PL, are in the notch. Pneumatic system is supplied by low pressure port from each engine. Ground crossfeed valve is closed and each engine bleed supplies its own air conditioning pack. All lights are extinguished on air bleed panel and all indications are green on system display cabin page. Between power levers in the wall and power lever above 37 degrees, high pressure valves remain closed. Air is supplied from low pressure port. No change on air bleed panel and on system display cabin page. When power levers are below 37 degrees, near flight idle, and if low pressure drops below 25 psi, high pressure valves are opened. Air is supplied from high pressure bleed port. No change on air bleed panel and on system display cabin page.
Your answer is correct. 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 Your answer is correct.
First choose on ground or in flight. Here the aircraft is on ground with 2 engines shut down and without propeller brake. Continue your selection and observe the result on the schematic. Engine 2 is running now. MFC detects only 1 engine bleed air shutoff valve open, the engine 2 bleed air shutoff valve, and opens the ground crossfeed valve. MFC detects 2 engine bleed air shutoff valves open and closes the ground crossfeed. The propeller brake is engaged. The MFC logic closes the engine 1 bleed air shutoff valve and consequently opens the ground crossfeed valve. MFC detects 2 engine bleed air shutoff valves open and closes the ground crossfeed. Now the aircraft is in flight, with 2 engines running, with the power levers above 37 degrees. Reminder: air supply is from low pressure port. Each engine supplies own side, and the high pressure bleed air valve is closed. The MFC detects 2 engines bleed air shutoff valve opened and closes the ground crossfeed valve. The propeller brake is inhibited in flight. The air conditioning system is supplied by air processed through 2 packs, which regulate airflow and temperature as required. The 2 packs are installed in the main landing gear fairings and operate automatically and independently. The left pack supplies cabin 32% and cockpit with conditioned air. The right pack supplies only the cabin. Note, if one pack is inoperative, the other one supplies both compartments through the mixing chamber. Hot air from the engines is admitted into the packs through the pack valves. The pack valve is pneumatically operated and electrically controlled. This butterfly valve has 2 functions: pack shut-off, pressure control and hence flow control. Normal or high flow are available. The selection of the high flow mode increases the pack entrance pressure, resulting in conditioning performance improvement. Without air pressure, and regardless of electrical command, the pack valve is spring-loaded closed. It will also close without electrical supply. Note, pack valves will be automatically closed in case of leak detection. air coming from engine is cooled the first time through the primary exchanger, located in the ram air tunnel. Then air is compressed and heated when it crosses the compressor. Air is cooled a second time in the secondary heat exchanger, and its moisture is condensed in a condenser before being extracted through a water extractor. Air is cooled through expansion in the turbine. Note: water collected by the water separator is sprayed on the heat exchangers to increase cooling efficiency. Air cooling is performed by two ground turbofans through turbo shutoff valves when IAS is less than 150 knots and landing gear is retracted for less than 10 minutes or extended. Note: in case of engine oil low pressure, the turbofan starts on the opposite side and is running as long as IAS is less than 150 knots and regardless of landing gear position. By ram air inlet when IAS is greater than 150 knots. Note: an incorrect position of the turbofan shutoff valve leads to the closure of associated pack valve. The temperature control system controls manually or automatically the flight compartment and cabin temperature. The air-conditioned temperature is obtained by mixing the air from a hot air source upstream of the conditioning pack, engine bleed air, a cold air source from the conditioning pack outlet. The right pack regulates cabin temperature and the left regulates flight compartment temperature. A mixing chamber is installed at the end of each pack. The purpose of the mixing chamber is to uniformly mix the temperate air coming from the packs with recirculated cabin air, and to substitute using the remaining pack the missing air in case of one pack failure. A ground cart connection enables air conditioning of the aircraft during ground operation. Air distribution ducts distribute conditioned air to the cabin and in the flight compartment. Conditioned air enters into the cabin below stowage compartments. Air is evacuated to the underfloor areas through openings on the lower side wall panel. One part of this air is evacuated outside through the outflow valves installed in the rear underfloor and the remaining part is recirculated with two recirculation fans located in the forward underfloor zone and mixed with temperate air coming from the mixing chambers. The individual air distribution system provides air for each passenger, for crew, and for cabin attendants. This system is composed of individual air distribution ducts, individual air outlets for passengers, cabin attendants, and pilots. The air ventilation system provides cooling of the electrical and electronic equipment through ambient air extraction to limit the internal equipment operating temperature. Ambient air is blown around the instruments, DUs, the central panels, the glare shield, the pedestal, and the windshield temperature controller, and goes through ducts to the extraction fan. It prevents smoke entering the flight compartment from the forward cargo area. In case of smoke in the aft cargo or lavatory compartment, aft smoke alert is displayed on EWD, continuous repetitive chime is activated, and extract fan is automatically closed to prevent smoke entering the flight compartment. Extraction is also provided for the overhead panel, the two electronic racks, the attitude and heading reference system, and the cockpit ambient temperature sensor box. Behind the extraction fan, a tapping brings air to ventilate the batteries. On ground, and when engine 1 is not running, air is evacuated overboard through the overboard ventilation valve. The underfloor ventilation valve is closed to avoid recirculation in underfloor areas. In flight or on ground with engine 1 running, the overboard ventilation valve is closed and the underfloor ventilation valve is open. One part of extracted air is recycled and evacuated underfloor. The remaining extracted air is evacuated into the forward cargo hold at floor level. In case of smoke in the forward cargo compartment, flight deck air extraction duct can be closed with a lever located by the right-hand side maintenance panel. The air bleed, the compartment temperature, and the avionics ventilation control panels are associated with a system display SD cabin page displayed on the MFD by default or on pilot request. Now observe the relationship between the air bleed control panel and the system display cabin page and their meaning. A dark push button indicates that pack valve push button is depressed and associated pack valve is open. It represents normal system operation in the on position. Label 1 is displayed on System Display Cabin page. A white off push button indicates that pack valve push button is released and pack valve is closed. This push button position corresponds to the off position, and label 2 is displayed on System Display Cabin page. An amber fault push button and flight warning system activation indicate a mismatch between the pack valve push button position and valve position, or that the valve is latched closed automatically in case of an overheat downstream of the pack compressor, temperature above 204 degrees Celsius. Now observe the relationship between the compartment temperature control panel and the system display cabin page and their meaning. The normal flow regulation push button. The normal position of the flow push button is released, and both pack valves are automatically regulated to deliver a 22 psi output pressure. High flow regulation. The high position of the push button is depressed. High is illuminated on the push button, and both pack valves are automatically regulated to deliver a higher flow of 30 psi output pressure. Air high flow is indicated on the system display cabin. Temperature cell push buttons. These push buttons are used to select temperature control valve operating mode between auto and manual. Automatic mode. The normal position of the temperature cell push button is depressed. This push button is dark and temperature auto is displayed on the system display cabin. Manual mode. When the manual mode is selected, the compartment temperature selector directly controls the temperature control valve. Manual in white is illuminated on the push button, and manual in cyan is displayed on the system display cabin. Note: when in manual mode, the pneumatic temperature limiter will keep the duct temperature below 88 degrees Celsius. When temperature cell is in manual position, compartment temperature selectors directly control the valve. In auto, it is controlled via an electronic controller. Duct overheat. When an overtemperature is detected in the duct, temperature above 92 degrees Celsius, overheat illuminates on the temperature cell push buttons. Overheat is displayed on system display cabin and flight warning system is activated. Temperature indications. The temperature indicator is a dual indicator enabling the crew to monitor both the duct inlet temperature and the ambient temperature of the compartment in the selected zone. The scale indicates the air temperature in degrees Celsius. Compartment selector switch. This toggle switch is used to select which compartment temperature is displayed: flight compartment or cabin. Recirculation fan push buttons. They are used to activate the associated recirculation fans. The normal position of this push button is depressed and the fans are running. The push buttons are dark and the fans are green on the system display. The fans recirculate a part of the cabin air to increase the supply of fresh conditioned air. The fan's speed ranges from the temperature control valve position. If the temperature at cabin floor level drops below 18 degrees Celsius, a higher speed is selected. The fan speed ranges from 1,500 to 2,200 RPM. A white off recirculation fan push button indicates that the push button is released and the associated recirculation fan is stopped. This push button state corresponds to the off position and the fan representation is white with recirculation on the system display cabin page. Note, with the fans off, all the air is supplied by the packs without recirculation. An amber fault push button and flight warning system activation indicate a recirculation fan low RPM, below 900 RPM, or a recirculation fan motor overheat. Fan is displayed in amber color on the system display cabin page. Now observe the relationship between the avionics ventilation control panel and the system display cabin page and their meaning. The exhaust mode push button has two functions. It controls the overboard valve when the overboard valve control switch is in the auto position and triggers a fault alarm in case of extract fan failure. Automatic mode. The normal position of the exhaust mode is depressed. The push button is dark and the overboard valve position depends on specific conditions. If aircraft is on ground with engine 1 not running, oil low pressure condition, extract fan runs continuously, overboard valve is full open, underfloor valve is closed. If aircraft is on ground or in flight with engine 1 running, extract fan runs continuously, overboard valve is fully closed, underfloor valve is open. An overboard cyan push button indicates that the exhaust mode push button is released, extract fan is off, overboard valve is partially open in flight, underfloor valve is closed. Note, with the aircraft on ground and external power available, if the exhaust mode is set to overboard, a ground mechanic call sounds and the intermediate position of the overboard valve is inhibited, remains open. The amber fault push button and flight warning system activation indicates that there is an extract fan failure, a fan motor overheat, or fan low speed. Note, during start sequence, the extract fan stops for 120 seconds to avoid pressure shocks. The fault light of the exhaust mode push button will illuminate, and its associated system display representation is displayed. Air overboard alarm is displayed on EWD without master caution and single chime. The central fault light indicates an overboard valve disagreement and activates the flight warning system. This means that when on ground with engine 1 not running, engine 1 oil low pressure displayed in the alert window, the overboard valve is not fully open, except with overboard valve switch on full close. Note, on ground, during engine 1 start sequence, the overboard valve moves from open to close, and during this time, the fault amber light is illuminated on avionic ventilation panel, and overboard valve amber is displayed on system display cabin. The fault light and its system display representation will be extinguished when the overboard valve reaches the selected position. However, when in flight or on ground with engine 1 running, the amber fault illuminated on the push button indicates that the overboard valve is not in the full close position, except with overboard valve control switch on full open. Note, the fault light extinguishes when the overboard valve reaches the selected position. The normal position of the overboard valve guarded switch is auto. In auto mode, the overboard valve position is a function of the exhaust mode and the aircraft condition, ground or flight. The valve position representations on the system display cabin is intuitive. Automatic mode, overboard valve, full open. Automatic mode, overboard valve in intermediate position. Automatic mode, overboard valve, full closed. Manual operation. The selector switch can be operated manually to full open. The overboard valve is fully open and displayed on the system display cabin page. Caution: do not select overboard valve full open if differential pressure exceeds 1 psi. This recommendation is to prevent any air duct damage due to heavy suction force. The selector switch can be manually positioned to full close. The overboard valve is fully closed and full close is shown on system display cabin page. The extract airflow lever isolates the flight deck and prevents smoke from the forward cargo compartment to enter the flight compartment. The normal position of the extract airflow lever is open. The extract airflow must be closed only in case of forward compartment smoke. Aircraft is on ground, both engines shut down. External power is connected. All white lights must be extinguished. Recirculation fans are now running. Engine 2 is started in hotel mode. Engine bleed valve opens, fault lights extinguish. Crossfeed valve opens. Pack 1 operates immediately. Fault light extinguishes on Pack 1 valve push button. Pack 2 operates after a time delay of 6 seconds. Fault light extinguishes on Pack 2 valve push button. Engine 1 is now started up. Engine 1 bleed fault light remains illuminated. Propeller brake is now released. Engine 1 bleed valve opens, cross-feed valve closes. Fault light and cross valve open extinguish. Aircraft has just taken off. gear is up. Aircraft speed is more than 150 knots. The turbo fans in the cooling units stop. Cabin temperature is selected on compartment temperature indicator. Full hot is selected on the cabin temperature selector. Manual is selected on the temperature cell push button. Temperature control valve remains open as long as duct temperature will not exceed 88 degrees Celsius. Duct temperature limiter. Ventilation normal operation. In normal configuration, the overboard valve control switch must be guarded in auto position. In auto position, the overboard valve position depends on the exhaust mode push-button selection, the aircraft situation, on ground, engine 1 running or not, or in flight. Now let's focus on the different aircraft configurations. Aircraft on ground, batteries or GPU on, engine 1 and 2 shut down, the overboard valve control switch guarded in auto position. When exhaust mode push-button selection is depressed, normal position, extract fan is running. Fault is illuminated on the exhaust mode push-button during 120 seconds during engine 1 and 2 start. The overboard valve is full open and green open door is displayed on system display cabin page. The underfloor valve is closed. No representation on system display cabin page. Prior to starting engine in hotel mode, with passenger door closed, cockpit communication hatch must be opened in order to equalize pressure due to air extraction through the overboard valve. Engine 2 is started in hotel mode. The extract fan stops for 120 seconds. Fault on exhaust mode push button illuminates. Extract fan symbol circle becomes amber with exhaust fault written next to it on system display cabin page. After 120 seconds, extract fan automatically starts. Fault light extinguishes and the extract fan symbol becomes green on system display cabin page. Fan rotation speed depends on flight deck temperature. Minimum speed when temperature is below 20 degrees Celsius and maximum speed when temperature is above 52 degrees Celsius. Summary. On ground, engine 2 running, in hotel mode or not, engine 1 shut down, overboard valve control switch guarded in auto position and exhaust mode push-button selection pressed in, the extract fan runs continuously. The overboard valve is full open. The underfloor valve is closed. Engine 1 is now started. Again, extract fan stops for 120 seconds. Fault on exhaust mode push button illuminates. Extract fan symbol circle becomes amber with exhaust fault written next to it on system display cabin page. The overboard ventilation valve moves from the open to the closed position and underfloor valve moves from the closed to the open position. The overboard valve fault amber light is illuminated and overboard valve amber symbol is displayed on system display cabin page. Now the overboard valve is closed and the overboard valve fault light extinguishes. The captain may close the cockpit communication hatch. 120 seconds after engine 1 start, extract fan starts again automatically. Fault light extinguishes and extract fan symbol becomes green on system display cabin page. Air is recirculated into the cabin through the underfloor valve. Notes: maximum differential pressure for overboard valve full open selection is 1 psi. The same configuration occurs in flight. Extract fan is running continuously, overboard ventilation valve is full closed, and underfloor valve is open. Aircraft configuration. Engine 1 and 2 running. Exhaust mode push button extinguished. Operate manually the overboard valve control switch. The overboard valve switch is set to full open. The overboard valve moves to full open position and the underfloor valve moves to closed position. During this time, the overboard valve fault light is illuminated and the overboard valve amber symbol is displayed on system display cabin page. Note: do not select overboard valve full open if differential pressure is above 1 psi. Now the overboard valve is full open and full open blue is displayed on system display cabin page. The underfloor valve is closed. The overboard valve switch is set to full close position. The overboard valve moves to full close position and the underfloor valve moves to open position. During this time, the overboard valve fault light is illuminated. Note: on ground for cold days, the switch must be moved on full close position in order to accelerate the cabin heating. Aircraft in flight. Engine 1 and 2 running. Overboard valve control switch guarded in auto position. Overboard valve full closed and underfloor valve full open. Note: in flight and in case of engine 1 or 2 flame out, MFC logic is to maintain overboard valve on full closed position to avoid depressurization. The exhaust mode push button is set to overboard position, push button released. Exhaust overboard is displayed on system display cabin page. The extract fan is off and a white circle is displayed on the system display cabin page. The overboard valve is partially open in flight and full open on ground. On system display cabin page, a door partially open in flight or full open on ground is displayed. The underfloor valve is closed. In case of air conditioning system failure, refer to the Master Minimum Equipment List, ATA 21.
Your answer is correct. 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 Your answer is correct.
First choose on ground or in flight. Here, the aircraft is on ground with two engines shut down. Overboard valve control switch guarded in auto position and the exhaust mode push button is pressed in. The extract fan is stopped. The overboard valve is full open and the underfloor valve is closed. Continue your selection and observe the result on the schematic. One engine is now started. After a 120-second delay, the extract fan runs. Overboard valve remains open. Underfloor ventilation valve is closed. Both engines are now running. The extract fan is stopped for 120 seconds. The overboard valve closes and the underfloor ventilation valve opens. After the 120 seconds delay, the extract fan runs continuously. Now the aircraft is in flight with two engines running. In normal operation, extract fan is running continuously, overboard ventilation valve is full closed, and underfloor valve is open. In case of engine 1 or 2 flame out, MFC logic is to maintain overboard valve on full closed position to avoid depressurization. Both engines are now running. The cabin and flight compartments must be pressurized to ensure comfort and safety for passengers and crew. The fuselage is pressurized from the front bulkhead to the rear bulkhead, except for the main and nose landing gear wheel wells. Compressed air is delivered by the packs. Pressure and its rate of change are controlled by the amount of cabin air discharged outboard. Air is discharged outboard via two outflow valves. An electro-pneumatic outflow valve driven by the automatic cabin pressure control system. A pneumatic outflow valve operated only in manual mode. When the system is in auto mode, the pneumatic outflow valve is slaved to the electro-pneumatic one. Their actuation are the same. Each outflow valve includes devices for the required safety function in case of controller failure. The positive differential pressure is limited to 6.35 psi by a manometric capsule. The negative differential pressure is limited to minus 0.5 psi by a non-return valve. The ambient pressure sensor APS is composed of 3 modules that allow acquisition, processing and transmission of cabin pressure data to the core avionics cabinets. Both signals, pressure and pressure variation, are designed to provide an output between 0.5 volts and 4.5 volts, allowing failure detections out of this range. Signals from APS are sent to the CAC, which converts them to establish cabin altitude in feet, determine the equivalent altitude associated with the cabin pressure, vertical speed in feet per minute, determine the equivalent altitude change associated with the pressure variation, differential pressure in PSI, determine the differential pressure between outside and inside aircraft. Auto mode. The digital controller is located on the Cabin Pressure Control System CPCS panel. It computes a theoretical cabin altitude and sends a signal to the electro-pneumatic outflow valve torque motor in order to adjust the actual cabin altitude by opening or closing the 2 outflow valves. It consists of an electronic box with a front panel and 3 plug-in modules as follows. One module contains the electrical supply circuit, the power output circuit and subsidiary circuits. One module holds all the input circuits, including the pressure sensor and the output circuits. The remaining module contains the central processor unit. The loss of electrical signal induces valve closure. In auto mode, outflow valves are driven by the digital controller according to aircraft altitude obtained from Air Data Computers ADC via the Core Avionics Cabinets CAC. In normal operation, the pressure reference is generated by ADC1 and Captain Altimeter Baro setting. In case of ADC1 failure, the pressure reference is generated by ADC2 and 1013.25 hectopascals. Landing elevation. Takeoff elevation memorized by the controller. Pressure cabin altitude given by a pressure transducer into the digital controller. Position of the aircraft doors. Manual mode. The electro-pneumatic outflow valve is maintained closed, and the pneumatic outflow valve controls the cabin outlet airflow. The control knob is used to select any cabin rate change from minus 1,500 feet per minute to plus 2,500 feet per minute. Ditching mode. 2 electrical motors, one for each outflow valve, maintain both outflow valves in closed position. Ditching mode is available in both automatic and manual modes. Dump function. A dump function is available to send a fully open electrical signal to the electro-pneumatic outflow valve. Dump function is available as long as pressurization system is in auto mode. The auto press panel is located on the main instrument panel. It is the interface between the crew and the fully automatic digital controller. It includes an elevation toggle switch, ELV set, with its landing elevation window, a cabin descent rate fast or normal selection, a test switch for testing the automatic system, and a dump function. The cabin press control panel is located on the main instrument panel. This panel includes the following controls: a mode selector, mode cell push button, a cabin altitude manual controller knob, a ditching ditch mode guarded push button. The cabin pressure displays, located on the lower part of the system display cabin page, give the following information: the differential pressure between the cabin pressure and the outside static pressure, the cabin altitude given by ambient pressure sensor via the Core Avionics Cabinet CAC, the rate of change of the cabin altitude. Differential pressure display. This display indicates the differential pressure in PSI. The normal differential pressure range is between 0 and 6 PSI. Indicating pointer and digital readout are green. The differential pressure pre-alert is displayed when the differential pressure reaches 6 PSI or drops below 0 PSI. The indicating pointer is displayed in amber, and the numerical value is in an amber box. A differential pressure alert is displayed in case of an excessive differential pressure, in excess of 6.35 psi or minus 0.5 psi. The indicating pointer is displayed in red, and the numerical value is in red reverse video. An invalid differential pressure, no data, is displayed in case of no or insufficient data provided by the CAC. The indicating pointer is removed and the numerical value is replaced by a series of dashes. Cabin altitude indication. In auto mode, when the mode cell push button is depressed, the actual cabin alt is obtained from cabin ambient pressure sensor via the CAC and is displayed in green. In manual mode, when the mode cell push button is in manual position, blue manual is displayed on this push button. On the system display cabin page, in the center of the cabin pressure displays, manual is displayed in blue. The actual cabin altitude alt title is displayed in blue and the numerical values in green. The target cabin altitude, target, is computed by the display unit itself when altitude is greater than 14,000 feet, or given by the FMS when lower or equal to 14,000 feet. The altitude value is displayed in amber for cabin altitudes above 6,750 feet. If the actual cabin altitude becomes greater than 3,050 meters, 10,075 feet, simultaneously a master warning alert is generated. The altitude is displayed in white in a red box. The XS cabin alt warning message is displayed on the EWD. Note: if cabin altitude exceeds 3,962 meters, 13,000 feet, the fully automatic digital controller fully closes both the outflow valves. If no data or no information is provided by the CAC, the actual cabin altitude is replaced by a series of dashes. If no data or no information is provided by the CAC, the target altitude is replaced by a series of dashes. On the system display cabin page, the cabin rate indication is located on the right-hand side of the cabin pressure displays. The display indicates the vertical speed in feet per minute. The digital display of the cabin altitude rate of change is on the right of the dial. The vertical speed range is between minus 2,500 feet per minute and plus 2,500 feet per minute. A positive vertical speed is indicated by the indicating pointer above 0 and the numerical value followed by the indication up. A negative vertical speed is indicated by the indicating pointer below 0 and the numerical value followed by the indication DN down. When the information provided by the CAC Core Avionic Cabinet is invalid due to none or insufficient data, the indicating pointer is removed and the digital display is replaced by a series of dashes. The landing elevation digital indicator displays in feet the elevation of the planned landing airport. The last two digits always display 0. All digits will extinguish in case of automatic system failure. The ELV set toggle switch is used to select the elevation of the planned landing airport elevation. The selection ranges from minus 1,500 feet to 10,000 feet and is set in 100-foot increments. The descent rate push button allows selection between normal and fast cabin altitude descent rate. The normal descent rate push button position is released. In this case, a maximum cabin rate of descent of minus 400 feet per minute is allowed. The fast cabin descent rate mode, when descent rate push button is depressed, increases the cabin rate up to minus 500 feet per minute. Fast is illuminated blue on the descent rate push button. When the test push button is depressed, the system is tested electrically. If the system is ready for use, the landing elevation digital indicator displays alternately 18,800 and minus 8,800. Fault light illuminates amber on the mode cell push button. Note: this test is inhibited in flight. The guarded dump push button allows selection of the dump function in auto mode only, regardless of differential pressure. Note, when the dump push button is released, light extinguished, pressurization is automatically regulated by the digital controller. When the dump push button is depressed, the digital controller is bypassed. An electrical signal is sent to the electro-pneumatic outflow valve, which opens both valves. The on light is illuminated blue on the push button. Caution: the dump push button is a guarded switch. No other safety device safeguards the dump push button from inadvertent use. The dump function fully depressurizes the cabin. The mode cell push button allows selection of the pressurization control mode. In automatic mode, the mode cell push button is depressed and extinguished. In this position, the fully automatic digital controller is in operation and controls the pressurization in auto mode. In auto mode, the cabin alt manual controller knob must be selected to normal on the green square in order not to interfere with the automatic pressurization regulation. In case of digital controller failure, fault amber light is illuminated on the cabin press panel. Air auto press is triggered on alerting window, and auto press amber color is displayed on system display cabin page. Note, in this case, pressurization must be manually controlled. Prior to engage manual mode, the manual controller knob must be selected from normal to manual position. Then mode cell push button is released. In manual mode, manual rate knob is used to adjust the cabin rate. The selection can be a minimum cabin rate of descent of -1500 feet per minute, or a maximum cabin rate of climb of +2,500 feet per minute. Note, to revert to automatic mode, first the mode cell push button must be depressed. Secondly, the manual rate knob must be set to normal position, green square. The ditch guarded push button allows selection of the ditch function, regardless of the mode cell push button positioning. Note, when the ditch push button is released, light extinguished, corresponding to the normal position, the fully automatic digital controller regulates aircraft pressurization. When the ditch guarded push button is depressed, both outflow valves are forced to be closed, regardless of mode cell push button position. A blue on light illuminates, flight warning system is activated, and air ditch amber message is displayed in the alerting window. Aircraft is on ground at the departure airport. Sea level pressure 1025 hectopascals is set on altimeter setting, using the baro set knob on the index control panel. The departure airport altitude, 1000 feet, is displayed on the altimeter and on the cabin altitude display. In normal operation, the cabin press is always in auto mode with the cabin alt knob in normal position with the pointer on the green square and a dark cabin press control panel. On the AutoPress panel, the elevation of the destination airport must be set in the landing elevation window using the ELV set switch. For our flight, the destination airport landing elevation is 1,500 feet. Up to 3,500 feet QFE, 3,000 feet above airport level, the cabin alt altitude remains at takeoff elevation in order to avoid any pressurization management in case of forced quick return, regardless of the selected landing elevation. Above 3,500 feet AAL, 4,500 feet AMSL in this example, the digital controller computes a theoretical cabin alt, ZCTH, according to current aircraft altitude. The cabin alt increases to catch up the ZCTH, or the landing elevation if it is higher than the ZCTH. When passing the transition altitude, the baro set is depressed to select STD. The altimeter displays now flight levels instead of altitudes. Below flight level 200, the cabin vertical speed is approximately the third of the aircraft vertical speed, with a maximum of 550 feet per minute. Let's consider a climb to flight level 250. ATC requests to expedite climb until flight level 150 at 2,500 feet per minute. As seen previously, the aircraft vertical speed must integrate the pressurization system capability to follow the altitude change. In this flight situation, the maximum cabin vertical speed value is plus 550 feet per minute, up to 20,000 feet, and the cabin alt cannot follow the new theoretical cabin alt, ZCTH. It will fall down below the ZCTH. Air traffic control requests to increase speed when passing flight level 150. Passing flight level 150, the crew reduces aircraft vertical speed from 2,500 feet per minute to 800 feet per minute. Reducing the vertical speed will allow the cabin altitude to catch up the theoretical cabin altitude. And before reaching the final cruise level 250, the cabin altitude will catch the theoretical cabin altitude to return to the nominal pressurization law, assuming the climb duration is long enough. Aircraft is now steady at flight level 250, with a cabin altitude of 6,700 feet. Let's return back earlier in the climb segment to see what happens during a continuous standard climb. The cabin vertical speed is still the third of the aircraft vertical speed. Above flight level 200, the cabin vertical speed is approximately the half of aircraft vertical speed, with a maximum of 550 feet per minute. Until flight level 250, which is the ATR maximum authorized operating flight level, the cabin alt and the differential pressure remain displayed in green. Now, if the aircraft climbs above flight level 250, the cabin alt and the differential pressure exceed the maximum values and are displayed in amber. Let's perform a standard descent with a 1500 feet per minute rate of descent. The maximum cabin alt rate of descent is minus 400 feet per minute. The cabin alt follows with a short delay the computed ZCTH. The crew expedites the descent with a higher rate of descent. The cabin alt cannot continue to follow the computed ZCTH. To prevent the computed and current cabin altitude difference increase, the fast descent rate function must be selected. The fast indication will illuminate blue on the push button, and the maximum cabin alt rate of descent is increased up to minus 500 feet per minute. The aircraft is now performing a normal descent with fast mode deselected. The aircraft is authorized to 3,000 feet sea level pressure, 1,025 hectopascals. Sea level pressure is set on the ICP. To avoid a cabin pressure bump at touchdown, the cabin altitude descends at 300 feet below the landing elevation. After touchdown, landing gear absorbers compression, the digital controller receives a depressurization signal. The cabin rate becomes 550 feet per minute until the outflow valves are fully opened. In case of air pressurization failure, refer to the Master Minimum Equipment List, Chapter 1, 21, Air Conditioning.
Your answer is correct. 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 Your answer is correct.